Exploring a function closure. So what's in a function's environment? So when you type the command ls of environment cube, you get n power. So you basically get what are the parameters that being used by a certain function or a method in when used in an environment. So you can also use get of n comma environment of cube. When you use that, you will get 3, the value of n that we normally use. So the same way, if you apply for ls of environment square, you'll get n comma power, the same variables. But when you get the values of n that is being used, get of n comma environment of square, then you will get 2. As in the function square uses the value 2, as in square uses exponential of 2, and cube it will be exponential of 3. Moving on, you'll see about lexical versus dynamic scoping. So let's have a function. We have assigned y as 10, and we have a function f wherein the function of x, y is assigned a value 2, and y square plus gx inside the function g of x. Now the g of x function is called, and we have a function g wherein function of x, x star y. So what really happens when we call f of 3? So what really happens is, even though the variable y is declared outside the function x, the variable that is declared inside the function y equal to 2 will be used for this computation. So basically what happens is, it will be y square, which means 2 square, plus g of 3. Again 3 will be passed on to this. So 3 star y. And what happens is 3 is multiplied by this y value will be taken from the value of y equal to 10, because this y starts within this bracket and ends within this bracket. The value of y equal to 2 will be within this brackets only. It's local. So outside the function, the value of y will be 10, which will be called for this function. So when x star y is called, this will be called. So when we call f of 3, so g of 3 will be called. So 3 star 10, 30, 30 plus 4, we'll get 34. That is the result that we get here. Moving on, with lexical scoping, the value of y in the function g is looked up in the environment in which the function was defined. So we are still going on with the previous example. In this case, the global environment, so the value of y is 10. So with the dynamic scoping, so dynamic scoping is when the value of y is looked up in the environment from which the function was called, sometimes referred to as the calling environment. In R, the calling environment is known as the parent frame. So the value of y would be 2. So moving on, uh, when a function is defined in the global environment and is subsequently called from the global environment, then the defining environment and the calling environments are the same. This can sometimes give the appearance of dynamic scoping. So we'll consider an example. So we'll have a function called g, which takes the parameter x, and in this we have a parameter called a, which is defined inside a equal to 3, and it performs the computation x plus a plus y. Now as you can see, when you call g of 2, what happens? The function x is called function of 2, and inside you'll have value of 3, a is there, value of x is there, but value of y, it is not defined anywhere. So as you can see, we'll get an error in g of 2, object y not found. So let's say if I declare outside, then y equal to 3. This is a global value which will be used in any function that calls a parameter y. So now if you call again g of 2, you will get x plus y, which is 3 plus 2 plus 3. You'll get 8. So that clearly defines, explaining the scope of each variables defined in your programming. So moving on, uh, what are the other languages that support lexical scoping? There are like multiple languages. The common Lisp language, all languages converge to Lisp, Python, Perl, and Scheme. All these languages support lexical scoping. So what are the consequences of lexical scoping? In R, all objects must be stored in memory. All functions must carry a pointer to their respective defining environments, which could be anywhere. So in S plus, free variables are always looked up in the global workspace. So everything can be stored on the disk because the defining environment of all functions is the same, because the defining environment here is the global workspace for S plus. So here all the variables can be easily stored in a disk. So what are the applications of this lexical scoping? So the first thing that comes into anyone's mind is optimization. So why is any of this information useful? Optimization routines in R, like optim, NLM, and optimize, they require you to pass a function whose argument is a vector of parameters. Example, a log likelihood. So, however, an object function might depend on a host of other things besides its parameters, like the data that it's using. So when writing software which does optimization, it may be desirable to allow the user to hold certain parameters fixed. So this is one of the biggest areas where lexical scoping is used. So these are examples for normal likelihood. So we are writing a constructor function. So a function make dot negative log likelihood, which is shorted as neg log like, is a function which has the data and where a boolean variable fixed equal to c false comma false. So within this you'll have params is fixed. You'll have an inner variable called params where you pass in the fixed boolean variable fixed into params, and you create one more function of p, in which, so you will have params of not fixed equal to in which params are not fixed, you are passing p. So again there is two variables, mu equal to params of 1 and sigma equal to params of 2. So this is how you create a normal likelihood. We can try this on R programming. You will be able to plot it. As soon as we finish the course of plotting, we'll have a good idea of how to plot a likelihood of normal curve. So wherein you have a equal to zero point 0.5 minus zero point 0.5 length into length of data into log of 2 into pi into sigma square. The same way you define a variable called b, where you have minus of 0.5 into sum of data minus mu square by sigma square. So and minus of a plus b. So this is optimizing a normal likelihood function. So here optimization functions in R minimize the function. So you need to use the negative likelihood. So when you set a seed, what happens is there is a random normal distribution function, which will create 100 random variables with mean equal to 1 and standard deviation equal to 2. So when you set seed, it will remember what are the random variables that are created, random integers or numbers that are created. So NLL is equal to make dot neg log like of normals. So you have the normal variables passed into the negative likelihood. So when you call NNL again, the function will be called, and this environment NNL data fixed params will show up, and this environment will be plotted as a normal likelihood. So how do you plot this likelihood? I'll give a small example here. So you have the NL variable here, make dot neg log like of normals comma c of 1 comma false, and we have a variable called x, which will be used for plotting, where we have a sequence 1.7 comma 1.9 length equal to 100, and y equal to s apply of x comma nll. Now if you plot of x comma exponential of minus of y minus min of y comma type L, this will give you a plotting graph of the negative likelihood. The same way you can just changing the values of c of false comma 2 and sequence from 0.5 to 1.5, you'll get same kind of negative likelihood with the values 0.5 to 1.5. So that's how you use the negative likelihood. So now coming to the summary of lexical scoping. So objective functions can be built which contain all of the necessary data for evaluating the function. So you don't have to carry around long argument list which are useful for interactive and exploratory work, and code can be simplified and cleaned up. So that's it about lexical scoping. And in case of if you need any reference, you can use the book by Robert Gentleman and Ross Ihaka, Lexical Scope and Statistical Computing. So with this, we finish our lexical scoping presentation.